All right, now that we've been working on solving systems of equations, we're now going to move on to bigger and better equations. We're now going to be working with three equations and three unknowns rather than just two equations. So you'll notice that we've got three equations here with the variables x, y, and z. So I can use the method of elimination to help me solve these. What we're going to do though is we're going to work and get these into a form known as row echelon form so that we can use something called back substitution, which will allow me to solve this equation or set of equations pretty quickly. So row echelon form, this set of original equations, can be simplified and reduced to give me this set of equations. X minus 2y plus 3z is 9. Y plus 4z is 7. And z equals 2. So if I can get it reduced to this form, which again we call row echelon form, and what you're doing is you're wanting it to kind of look like stair steps. And if we can, we'd like our leading coefficients to be 1. Now, we can always get them to equal 1, but what happens is sometimes we end up with some fractions. So you don't have to get them to equal 1. You're going to see one of the examples that I do. I don't want to get it to equal 1 because it'll give me fractions. But if I can get it in the stair-step form, then I can use what we call back substitution to find my values for what x will equal, y will equal, and z will equal. We already know that z equals 2. So what I can now do, let's go ahead and look at what back substitution would mean. I'm going to take that variable and I'm going to go back a step and I'm going to substitute that in. So I would get y plus 4 times 2, because z is 2, would equal 7. Well, that's y plus 8 equals 7, which means y has to be negative 1. And now I can back substitute those two and figure out what x is. So I have x minus 2 times y plus 3 times z is supposed to equal 9. Let's try to break that off there. So that's x plus 2 plus 6 equals 9, or x plus 8 equals 9, which gives me that x equals 1. So we now know that x equals 1, and we've solved this system of equations, and so our solution would be the ordered triple 1, negative 1, 2. And one of the things I noticed as I've graded some of your all's papers, y'all are not writing your final answers as ordered pairs or now as ordered triples, and you should. So the rest of this video is going to be working on how did we take this system of equations and come up with our row echelon form of x minus 2y plus 3z equals 9, y plus 4z equals 7, and z equals 2. So how did I get from here to this second set of equations? So that's really what we're working on, and that's what your assignment is really going to involve. So there's actually multiple ways to do this, but this way will always work. So what you're going to do is you're going to work with row 1 and row 2, and you're going to eliminate the x, just like we would use elimination method with two variables, but we want to eliminate the x out of row 2. So I want to get rid of that. So I always keep, and you'll notice that in the final not matrix, we're going to matrices, but in the final system of equations, the first equation is the same as the one you started with. So I try not to bother that equation, and then I'm going to use it to eliminate the variables that I need to for the other equations. So to get rid of the x in equation 1, I just need to add row 1 and row 2. All right, so if I add those, x and negative x will give me 0. Negative 2y and 3y will give me y. 3z and z will give me 4z. And then 9 and negative 2 will give me 7. And notice that right now, that's my second equation. So we've got the first and the second to be the correct equations. Now what I'm going to need to do is I'm going to take row 1 and row 3. And I'm going to manipulate those till I can get rid of the x again. Well, if row 1 has an x, that's a 1x, and row 3 has a 2x, I'm going to need to multiply the first equation by 2, negative 2, and then add it to the third one. So I'm just going to kind of come over here on the side and do my work. So I would have negative 2x plus 4y minus 6z equals negative 18. And then I'll keep the third equation. So 2x minus 5y plus 5z is going to equal 17. And now I'll add those two together. Notice the x's will cancel. I'll get negative y minus z equals negative 1. And now I'm almost done. The last thing I need to do is I need to take row 2 and row 3. So you do 1 and 2, 1 and 3, 2 and 3. So now I'm going to take row 2 and row 3, and I'm going to manipulate those so that I can get rid of the y that's the leading coefficient in row 3. So I want to get rid of this y. Well, notice that I have positive y and negative y. So I'm going to go ahead and keep my first two equations, and this should end up being my final system of equations before I would back substitute. So I'm going to keep row 1 and row 2. And then if I add row 2 and row 3, I'm going to get 0. And then I get 3z equals 6. Well, from there, we can see that if I divide that bottom equation by 3, I'm actually going to get z equals 2. And notice that that is my equations now that I had in the final row echelon form. So there's the first equation. Here's my second set, and there's my third. And now at this point, you would just do back substitution, which we just did, to get what x and y and z would be equal to. All right, so let's look at a couple more examples because these really do take a little time to get used to. But once you get used to them, there's a process to it, and you can follow it every time. So remember, we want to do row 1 and row 2. Then we're going to do row 1 and row 3. And then we're going to do row 2 and row 3. Now, that is not the only way you can do these, but that definitely will always work for you, and you should be able to work through these. So we're going to keep the first equation. So I'll try to keep my final system of equations here before we back substitute. So if I take row 1 and row 2, I'm going to need to multiply row 1 by 2 so that it'll eliminate with the x in row 2. So 2x plus 4y minus 2z equals 26, and negative 2x plus y plus z equals negative 1. So we'll add those two together, and we're going to get 5y minus z equals 25. So I'm going to go ahead and bring that down to my final system. Then I'm going to go ahead and I'm going to do row 1 and row 3. So notice that we've got an x and a 3x. So I'm going to multiply the top equation by negative 3. So negative 3x minus 6y plus 3z equals negative 39. And I'll keep row 3, 3x minus 4y plus 3z equals negative 11, and we'll add those. Now the x's cancel, we get negative 10y plus 6z equals 50. But that's not my final equation or system yet, because we need to get this last equation to be just about z. So we're going to take these two because there's row 2, and here's my new row 3, and I'm going to work with those. So if I multiply the 5y minus z equals 25 by 2, I'm going to get 10y minus 2z equals 50. And then row 3 that we just got was negative 10y plus 6z equals, and that should be negative 50, because I had negative 39 plus negative 11. But now look what happens. I get 4z equals 0. But really, if 4z equals 0, then I can go back and just make this z equals 0. And now we're ready to do our back substitution, because once we know what z is, I can back substitute until I can get back up to what x and y are equal. So let's see if we can squeeze this in here. So we've got 5y minus z, which would be 0, equals 25. Well, that's going to mean that y equals 5. And then we'll come over here and see if we can't squeeze in and solve for x. So x plus 2y, y is 5, so that would be 10, minus z, which is 0, would equal 13. But then that would be x plus 10 equals 13, and that means x has to equal 3. So now I have my ordered triple. So x was 3, y was 5, and z was 0. So that's the solution to my system of equations. And guys, you can always check that by going back and substituting in all three of those variables into the original system of equations and make sure that it makes that true. All right, last example. So I am on this one. Notice that my coefficients are 4, 2, and 1. So I'm actually just going to rearrange this because the order of the equations really doesn't matter. And I'm going to put the equation that has the leading coefficient of 1 first. So I'm going to rewrite this. Now, you don't have to do this. I just kind of prefer it. And then the other two, it doesn't matter what order you put them in. So I'm going to take this first equation and I'm going to multiply it by negative 4, so that I can eliminate the x in the second equation. So let's go down here. Here's going to be hopefully my finalized system. So if I take the first one times negative 4, I'm going to get negative 4x minus 4y minus 4z equals positive 12 now. And 4x plus y minus 3z is going to equal 11. So if I add those two together, I'm going to get negative 3y minus 7z equals 23. So there's my second equation now. That was row 1 and row 2. Now I'm going to do row 1 and row 3. So I multiply the first one by negative 2 so that I can eliminate this positive 2. So negative 2x minus 2y minus 2z is going to equal positive 6. And then row 3 was 2x minus 3y plus 2z equals 9. Add that together, I get negative 5y equals 15. Well, actually, I can go ahead at this point, and I don't care if you don't end up getting it simplified down to row echelon form, as long as you can find the solutions. I can go ahead here and divide and get that y would equal negative 3. Now, once I know that, we can back substitute, and we'll be able to figure out z. So I have negative 3 times negative 3 minus 7z equals 23. So that's 9 minus 7z. But subtract off the 9, and I get negative 7z equals 14, which means z is negative 2. And then we'll back substitute one more time and get x plus y, but we know y is negative 3, plus z, which is negative 2, is equal to negative 3. So we actually have x minus 5 equals negative 3, which makes x equal to 2. And now I know my ordered triple, that's my solution. So x is 2, y was negative 3, and z was negative 2. So there is the solution to that system of equations.